Do you believe it's possible that we might actually be living inside the mind of a giant living being? It may sound unbelievable at first, but as humanity delves deeper into the nature of the universe, some scientists have discovered a striking similarity between the large-scale structure of the cosmos and the neural networks inside the human brain. According to astronomers, the observable universe today stretches across an astonishing 93 billion light-years and contains over 2 trillion galaxies, each filled with tens of billions of stars. And these galaxies and galaxy clusters form an incredibly complex cosmic web structure, almost like a massive intergalactic internet shaped largely by the interaction between gravity and dark matter, exhibiting a pattern known as fractal geometry. Now, when you compare this to the human brain, which consists of approximately 86 billion neurons, with each of these neurons is connected to thousands of others through synapses, forming an incredibly complex web of interactions that enables us to think, feel, and experience consciousness itself. So what exactly are the similarities between the large-scale structure of the universe and the neural networks of the human brain? From a macroscopic perspective, galaxies, clusters, and dark matter filaments in the universe are arranged in an intricate web that looks surprisingly similar to the network of neurons in our brains. Both cosmologists and neuroscientists have observed that the way these systems are distributed, their connection patterns, and their overall complexity reveal astonishing parallels. In the universe, galaxies function as the basic structural units, just as neurons do in the brain. Galaxies interact with each other through gravitational forces, while neurons communicate through synapses. The dark matter filaments connecting galaxies resemble the synapses that link neurons together, forming the backbone of the universe's large-scale structure. Much like synaptic pathways support the brain's information, transmission, and processing. But it doesn't stop at structure functionally. These two systems also share some fascinating similarities. Neural networks are designed to process and transmit information. And in the cosmos, gravitational waves, photons, and various forms of energy are constantly being exchanged and propagated across vast distances, effectively transmitting information on a cosmic scale. Additionally, neural networks undergo a process known as neuroplasticity, which allows them to self-organize and adapt. And in a surprisingly parallel way, galaxies and clusters within the universe also appear to self-regulate and evolve through gravitational interactions and other fundamental forces. This striking similarity has led many scientists to reflect more deeply on the possibility that we might, in fact, be living inside the consciousness of a colossal living entity. Interestingly, this idea isn't entirely new. Both science and philosophy have explored similar concepts before. Some scientists have proposed that our universe could be a highly advanced computer simulation created by a superior civilization, in which case our entire reality would be nothing more than a complex digital construct, operating much like an artificial neural network inside a machine. On the philosophical side, some thinkers argue that consciousness may be a universal phenomenon, suggesting that every material entity, including the entire universe, might possess some form of awareness. If the universe itself holds a form of consciousness, then each one of us might simply be a tiny fragment of a vast and unified mind. That said, these ideas remain speculative, rooted in theoretical interpretations rather than concrete evidence, and whether we are truly living inside the mind of a giant being is still a question without a definitive answer. Nevertheless, the undeniable parallels between the universe and neural networks continue to inspire profound questions about the true nature of our reality, and in the future, scientists may uncover more details about the connection between cosmic structures and cognitive systems, potentially expanding our understanding of the universe in ways we can't yet imagine. Just 3 days later, another atomic bomb, this one nicknamed Fat Man, was dropped on Nagasaki, releasing energy equivalent to 21,000 tons of TNT. These two devastating explosions killed tens of thousands of people instantly, and in the weeks and months that followed, even more lives were lost due to radiation exposure. It was at that moment in history that humanity truly came to understand the terrifying destructive power of nuclear weapons. Unlike conventional bombs, atomic bombs release energy through nuclear fission, the process of splitting atomic nuclei, typically using uranium-235 or plutonium-239. When these atoms are struck by neutrons, they split into smaller nuclei and release several more neutrons, along with an enormous amount of energy. These released neutrons go on to hit more atomic nuclei, creating a chain reaction that unleashes even more energy in a matter of microseconds. But as powerful as atomic bombs are, hydrogen bombs or thermonuclear bombs are, on an entirely different level. They operate on the principle of nuclear fusion, the same process that powers the stars, where atomic nuclei, usually isotopes of hydrogen, are forced to fuse together under extreme heat and pressure, forming heavier nuclei and releasing an incredible amount of energy. To achieve these extreme conditions, a hydrogen bomb actually requires the detonation of an atomic bomb first, which provides the intense heat and pressure needed to ignite the fusion reaction. The most powerful nuclear weapon ever created by humanity is the Soviet Tsar Bomba, a hydrogen bomb that unleashed an energy equivalent to 58 million tons of TNT. The Tsar Bomba measured 8 meters in length, nearly 2.6 meters in diameter, and weighed over 27 tons. If dismantled, you'd find a small spherical atomic bomb at its core, with a plutonium-based fission trigger at the center. Surrounding this was a layer of conventional chemical explosives, and behind it, a cylindrical casing made of uranium, with the fusion-fueled deuterium and tritium housed in the center of the bomb. At 11:32 a.m. on October 30th, 1961, a Soviet pilot dropped the bomb from a strategic bomber over the remote island of Novaya. As the bomb fell, a barometric sensor triggered at an altitude of 4 kilometers, setting off an electric spark that ignited the chemical explosives. The explosion compressed the uranium and released neutrons, which struck plutonium nuclei, splitting them into 2 smaller nuclei, while also releasing 2 or 3 more neutrons. These newly released neutrons then struck other plutonium atoms, creating a rapid chain reaction of nuclear fission. The detonation of the atomic core generated temperatures and pressures even higher than those found at the center of the sun, and under such extreme conditions, the fusion fuel inside the bomb ignited, causing hydrogen nuclei to merge and release even more neutrons. These fusion-generated neutrons then struck the uranium casing, causing additional fission reactions, which in turn compressed the fusion fuel even more, triggering further fusion in a self-reinforcing loop that resulted in a colossal explosion. The fireball created by the Tsar Bomba reached a diameter of 8 kilometers, and its mushroom cloud soared over 60 kilometers into the sky. Within a 55-kilometer radius, all structures were completely destroyed, while buildings as far as 160 kilometers away suffered varying levels of damage. The heat generated was so intense that it could cause third-degree burns up to 100 kilometers from ground zero, and the flash of the blast was powerful enough to cause eye injuries or even blindness in people 50 kilometers away. The shockwave generated by the explosion was equivalent to a magnitude 5.0 to 5.25 earthquake. From the sheer scale of its destructive power, it's easy to imagine just how terrifying the Tsar Bomba truly was.
If you enjoyed this video, don't forget to leave a like and subscribe. More mind-blowing content is coming soon. See you next time.